As software engineers and architects, you have all come across architectural characteristics, right? The availability, scalability, performance, security, safety of the system. Right? But um, if you want to know how to identify these architectural characteristics from a given problem statement, if so, this session is for you. To create an architecture or determine the availability of an existing architecture, architects must analyze two things: architectural characteristics and domain. Right? Domain is where we define the what we are expecting from the system, what the system is, the functionality, what is the business requirement. Right? Example, banking system, food ordering system, right? That defines the problem statement. Now, how do we identify the architectural characteristics from that problem statement? Right? There are three ways to uncover architectural characteristics. It is a systematic approach. Um, we have been dealing with all of this, but in a random way. We exactly don't know how to derive these architectural characteristics. So let us go deep into it. Now, the very first place that we need to look for architectural characteristics is domain concerns. Right? What the problem statement, what is the business requirement, what are the domain concerns, right? What it is trying to tell. So, how do we, in real enterprise examples, how do we achieve this? So, generally, there are stakeholders, right? It is not only about building the architectural solution alone, but talking to stakeholders and understanding what is the business requirement, right? But it is not that straightforward um, because architects speak in language of scalability, interoperability, tolerance, learnability, availability, all of this. But domain stakeholders talk about mergers, acquisitions, user satisfaction, time to market, right? So now the architect and the stakeholder don't understand each other. So what happens? It leads to lost in translation kind of problem. Right? Now it is architect's responsibility to map those stakeholder business concerns into architectural characteristics. Example, when we say user satisfaction, right? User satisfaction. This can be mapped to performance, right? The better the system is performing, the more satisfied will be the user, right? Availability. If the system is able to serve uninterrupted, then the user will be happy. So now we are mapping the domain concerns into architectural characteristics. This is one way of identifying architectural characteristics, right? From domain concerns. Domain concerns. Uh, the next place that we need to look for architectural characteristics is sometimes there is a business requirement. Example, where the stakeholder or the business is saying, make sure that the response time of the system is less than 100 milliseconds. Right? Now, um, any architect, straightforwardly, this he will map this to, he or she will map this to performance, right? Because it is talking about the response time. Now, it is not enough because uh, For a system to be able to perform better, first it should be available, right? Otherwise, how will it even perform better if it is not at all available? So now, availability is a derived architectural characteristic. The business or the stakeholder is not saying this explicitly, but as an architect, we have to look into that direction, right? To be able to perform better, it should be available. To be able to perform better, it should be reliable, right? If it is not reliable, then how can we even depend on that system, right? And it should be scalable because we are never restricting the number of users, right? Are we telling anybody like only these 10 users can use the system or any given point of time? No, right? We can expect all type of users at any time of the system operation. That means the system should be able to handle that traffic and scale through. That means to perform better, the system should be scalable, right? And say there is some disaster happened, the system is down for some time. Now, how fast it can come up and start serving customer, right? Otherwise, how can it perform better? So now, what is it? Recovery for the system to come back and start serving. That is recovery. If the system is not coming back, how can it perform better, right? And the system is not robust, or if it is not able to handle corner cases, or for example, transactions, if it is not calculating the credit and debit correctly, right? Then how can it perform better? Now, the performance is irrelevant here. If the system itself is not having the expected functionality, then performance is irrelevant, right? So these are all the derived architectures, architectural characteristics, right? Again, the stakeholder is not explicitly saying this. The domain concern is not explicitly saying this. So what happens is many business goals start as a composite architectural characteristics, right? It just says my system should serve or respond within this time, right? Now the architect should decompose it. The composite architectural characteristics should be decomposed to identify what all system should serve, right? These are all the basic functionalities, the bare minimum basic functionalities that a system should offer. So this is how we identify the architectural characteristics, right? That is from composite requirement. Now, the third way of identifying architectural characteristics is architect's domain knowledge, right? Example, mm, um, say you are designing a application that handles class registration for university students, right? Um, Let us say we have 1,000 students and they have given 10 hours for registration. All those 1,000 students has to register within 10 hours, right? So, mm, what we can expect from this scenario? Do we expect the 1,000 students distribute 10 hours between themselves and register in a sequential manner? Like first 1 hour, 100 students will register, right? A second hour, the next 100 student will register till 1,000, right? So can we expect this kind of behavior from students, right? For that matter, not from any system, right? We don't know when the user is making a request. The system is available, it is there serving, but we don't know, right? We cannot predict the pattern. Now, in the typical case of university students, what we can expect? All of them might try to register at last 10 minutes. Now, for long period of time, the system is idle. It is not having any traffic, but only at the last 10 minutes, all 1,000 users are trying to access the system. Now, the system should be capable to handle that load, right? The system should be scalable. It should be robust to handle that. Now, is anybody explicitly giving this requirement? No. This comes from architect's internal domain knowledge. So if this is the case, probably this is how the user behavior will be, right? And again for banking systems, right? Banking systems also like around the holidays, there are more transactions, right? If there is any new policy change, there are more transactions suddenly. And even for the food ordering systems, around the peak hours, lunch hours, um, there is a lot of traffic. Around evening, snacks time, there is a lot of traffic, right? So now the architect should be able to understand the domain and analyze what can be the behavior, how the system should perform. So this is the third way of identifying architectural characteristics, that is domain knowledge. Domain knowledge. Right? Now, there are two categories we can divide architectural characteristics. One, implicit. The other is explicit. Right? What are implicit architectural characteristics? They are not given in the requirement documentation. Right? They are derived architectural characteristics. They are derived from the stakeholder discussions, the business concerns, the composite architectural characteristics from the domain knowledge of an architect. These are all implicit, implicit architectural characteristics. What are explicit architectural characteristics? You get them in your requirement. The business is saying, this is my requirement. Again, for example, my system should serve 1 million customers within this time period, right? Now, we have this data, we have number of users, right? Now we can analyze how can we scale. So scalability is now defined in the requirement, right? The robustness is defined in the requirement. Or um, the business might say that the system should be available from this to this time, right? Maybe morning 10 o'clock to evening 7 o'clock. That means the availability, right? Now, these architectural characteristics are coming in the requirement documentation. So they are explicitly called out. These are explicit architectural characteristics. Right? In the next session, we will break down and identify architectural characteristics from a real world business example. We'll read line by line the require problem statement, then we'll identify the architectural characteristics out of it. Thank you for your valuable time. In the next sessions, we will continue exploring more software architectural topics. This session is part of software architecture series. There are more concepts covered on all the other topics of software architecture. Please take a look. Thank you.